Hi everyone. In this section, we are going to learn about distributions of two population means. Here, I assume that you have learned about one population, their distribution, and hypothesis testing. As I mentioned, in this section, we are going to learn about two populations to make decisions. Here you can see we have taken population 1 and population 2. They are selected separately. So I have mentioned size n1 is the population 1 size and the population 2 size is n2. In this case, you can see this population n1 and n2 sizes may or may not be equal. From population 1, we have taken sample 1 which size is n1, and from the population 2 we have taken sample 2 size is n2. These sample 1 and sample 2 are independent. Now we are going to find the distribution of x1 bar minus x2 bar. Suppose that x1 is normal distributed variable with mean mu1 and variance sigma 1 squared, and also x2 is normal distributed variable with mean mu2 and variance is sigma 2 squared. Then for independent samples of size n1 and n2 from the two populations, we can write mean of x1 bar minus x2 bar is equal to the mu1 minus mu2, which means the difference of population means, and the standard deviation of x1 bar minus x2 bar equal to square root of sigma 1 squared over n1 plus sigma 2 squared over n2. x1 bar minus x2 bar is normal distributed with mean mu x1 bar minus x2 bar, and standard deviation sigma x1 bar minus x2 bar. We can denote it like this in general. We can get the same result by using central limit theorem if we have enough sample size or large enough sample size regardless of their distribution. Now we are going to standardize these x1 bar minus x2 bar, which means standardized version of x1 bar minus x2 bar. We denote it using capital Z. C equal x1 bar minus x2 bar minus mu1 minus mu2 divide by square root of sigma 1 squared over n1 plus sigma 2 squared over n2. In general, we can denote this using C has a normal distribution with mean 0 and standard deviation is 1. This is how we denote it in general. Okay, let's see an example and see how it works. I have an example. It says that suppose that 30 faculty members were selected from private institution and 35 faculty members public institutions were selected. Both populations are normal distributed. Average salary for faculty member of all private institutions is $98 and for faculty member of public universities $93 per annum in thousands. Standard deviation for private institution in $2 and for the public university it is $3.5 in thousands. Our goal is to find the distribution for the difference of the sample mean salary, which means salaries are in thousands, so we need to find the sample mean salaries in thousands. Here you can see I have colored in red color and blue colors. Population 1 details I have mentioned in red color. and also population 2 details I have mentioned in blue colors. So with this information, we can solve this problem. Let's see how we can solve this problem. First, we have to pick what is our x1. We have to denote it. So I'll consider x1 is the salary of private institution, x2 is the salary of public institution. I can calculate, I can get my mu1 from the problem is 98, mu2 is 93, mean of mean of the population 1 is 98, mean of the population 2 is 93. So sigma 1 is squared, which means where standard deviation is squared of the population 1 is 2 to the power 2, which means 4. Uh, stand, uh, Standard deviation squared of population 2 equal 3.5 squared. Then we can calculate the mean of x1 bar minus x2 bar. It is equal to the mean difference of two populations, which mean mu1 minus mu2. Simply 98 minus 3 is 5. And also we can calculate the standard deviation of x1 bar minus x2 bar. Our equation is square root of sigma 1 squared over n1 plus sigma 2 squared over n2. So we can plug the values. Sigma 1 squared is 2 squared, n1 is 30, sigma 2 squared is 3.5 squared, and n2 is 35. So when you simplify this, we'll be having 0.7. So standard deviation of x1 bar minus x2 bar is 0.7. We can collect these two values and we can say that x1 bar minus x2 bar is normal distributed with mean 5 and standard deviation is 0.7. So this is the answer for this question. Now I'm going to sum up what we have discussed in this section. First, we check what is a population and sample. Next, we've learned that how to calculate the mean of x1 bar minus x2 bar. It is exactly same as the difference mean between two populations, which mean mu1 minus mu2. And next, we saw that sigma x1 bar minus x2 bar is equal to the square root of sigma 1 squared over n1 plus sigma 2 squared over n2. We standardize our x1 bar minus x2 bar and we denote it using capital letter Z. So C equal x1 bar minus x2 bar minus mu1 minus mu2 over sigma 1 squared over n1 plus sigma 2 squared over n2. And also in general we can denote Z has a standard normal distribution which has mean 0 and standard deviation is 1.